Welcome back, class. This will be 8.1c properties of rational exponents. So now we're going to be adding some new stuff, but it will blend into the review of what we've learned in these past few days. So in this first case, we have two, we have a fourth root and a cubed root, but in both cases our base is the same. So because of that, when we rewrite it, so this first one, there's an implied exponent of 1. So this is a review to yesterday. This index goes in the denominator, so it's 5 to the 4th. And then we're going to cube it here times this one will be similar, where then it's 5 to the 3rd. Now, in this first case, this is a review back to that first day where it's a power to a power, so we're going to multiply that. So a fourth times 3 is the same as a fourth times 3 over 1, so we multiply across, so it's going to be 5 to the 3/4 power times 5 to the 3rd power. So now it kind of looks familiar where we have the product and exponents. So since we're multiplying and the bases are the same, we're going to add the exponents together. But we don't have a common denominator between the two, so we have to find the common denominator. Factors of 4 are 4, 8, and 12, and the factors of 3 are 3, 6, 9, 12, so the common denominator will be 12. So for 3/4, when we make that a denominator of 12, we multiply by 3, so then it's 9/12, and then for a third, that will be 4/12. So now when we add 9/12 plus 4/12, we're going to get 13/12 here. So to be clear, when we rewrote this, we got 5 to the 9/12 plus 4/12, which then equals 5 to the 13/12. From here, now we have our denominator, so our index. So it's going to be the 12th root of 5 to the 13th. Or in this case, we could write it as the 12th root of 5 to the 13th. And since we have one more factor of 5 in here than our index, we can pull out a factor of 5. So then it's the 12th root of 5. So then this would be our final product here. Next, now in this case we do not have the same base, but we do have the same exponent. So now when we have the same exponent, we can multiply what's on the inside together. So when we rewrite this, we get the cubed root of 25 times 5. Before I multiply 25 times 5, I can see that the factors are going to be 5 times 5 times 5. And since it's cubic, we want those three factors. So the cubed root of 25 times 5 is just going to be 5. Now in this case, we have the same base, but we have the product between the two. And this is a little more review again. And since we have the product, it's going to be adding the exponents. So 2 plus radical 3. This will be simplified since we have an irrational and a real or an integer here. So this will be in simplest form. Some review here. So actually, let's start with the variables first, because this will look the most familiar. When we have x to the m over x to the n, and it's the quotient, that's x to the m minus n. So in this case, we have x to the 5th over x to the 3rd, so we would take 5 minus 3, so that would just be x squared. So in this case, this first one here, we have the same base, and we have exponents, so it would look pretty similar, where then we have 2 squared, because we subtracted those exponents, and since 5 is greater than 3, it's going to be positive here. So 2 squared then will simplify to 4, we have a quotient with the same base, so now we're going to subtract. So here we are going to want to simplify, so I'm going to do it down here. 2/3 minus 1/3 is going to be 1/3. So what we have left then is the base to the third power, which can be written, since this is our index, as the I'm blanking on what it's called here, but this is what it would simplify to. All right, in this case here, now we have 5 squared, and it's a power to a power, so we have to multiply those. So we have 5 to the 2 times 3, 5 squared times 3. So that simplifies to 5 to the 6th power. I'm pretty sure I calculated that. It should be 15,625. In this case, it's power to the power again, so we have 5 to the 2/3 times, it'd be 3/1, which simplifies, since we multiply straight across, to 5 to the 6/3, which will simplify, when we take 6 divided by 3, is 2. So that would be 5 squared, which is 25. All right, in this case, we still have a power to a power. The radical may look, I don't know, a little challenging, but we can still use the properties that we know. So if it's a power to a power, we're multiplying. And when you take the square root of something times the square root of that same thing, it would just be x to the 5th. And to be clear, when we do that, we can multiply this stuff on the inside, because we would have the same exponent or index. So then we would have x to the square root of 25th, which simplifies to x to the 5th. And then in this case, I probably should have started here, we have power to the power, so this would be x to the 6th. All right, example 4, simplifying exponent rules. I'm going to start with this one. So it's to the negative exponent, so we need to do the reciprocal, so then that'd be 1 over x squared. Now I'm going to go all the way to the one to the left. Now it's 5 to the negative 2. So we rewrite that as 1 over 5 squared. Then we can simplify and make it 1 over 25. And with this middle one here, it's going to be an exponent, and it's rational, so it's 1 over 25 to the half power. Our index is 2, so then we can rewrite that as 1 over, it'd be the square root of 25. So we don't need this 2, but just to be clear, I lost my cursor, the 2 is the index, and that then goes out front. But this square root, we could have left it without. But when we take the square root of 25, we just get 5. So then we have 1/5 here. Finally, we're going to simplify using exponent rules. So it looks like a lot, but if we just take it step by step, it won't be so bad. So first I'm going to do 18 divided by 6. 6 goes into 18 3 times, so we're left with 3/1. This next one is r to the 1st over r to the 4th. That's a 4th. So it's a quotient and the same base, so we're going to subtract. So r to the 1st minus a 4th. In this case, 1 can be rewritten as 4/4. So when we subtract here, this is going to be r to the 3/4. And since 1 is bigger than a 4th, it's left on top, so 3/4. There's nothing in the denominator with an s, so s will remain the same, to the 2/3. And then now we have a negative exponent, so we're going to want to take the reciprocal and bring that t to the negative 3 up. So then we're going to have t cubed, because when we take the reciprocal of 1 over t to the negative 3, the reciprocal is just going to be t cubed. So in this case, this will be simplified here. I guess you could rewrite it as just the product on top. 3 to the 4th times s to the 2/3 times t cubed. So for this case, that would be simplified down. And that's all we have for today. They're a little shorter than the last two. So thanks for listening.